So we're going to run through. We see how best we can go. The first question is talking about, now if you have seen how the papers are brought, the first part, mostly measurements, just the advancement of topics the way they are in the syllabus. So that's why all the grades, the content that you learn are very important. The diagram below shows a vernier caliper with its jaws closed. Now, when the jaws are closed, what do we expect? When the jaws are closed, we expect to find the measurements to be 0, 0. Because remember, among the rules that we are given that we have to observe in that when you are using the vernier caliper, is that the instrument should be zeroed. So that when the instrument is zeroed, and when the jaws are closed, we expect on the main scale to have a 0, as well as on the vernier scale to have a 0 in that such a manner, so that when we find the readings on the main the reading of the instrument, it has to give us 0.0 centimeters. Now, even after the jaws are closed, we can see that the consignment of the lines on the jaws on the main scale and the vernier scale cannot give us the 0 readings. That means there is an error. So what is the error? Therefore, the error is the answer we will find when we get the readings on the instrument. And according to what we know, is that when you're taking the readings, the first thing that we have to do, you get the number from the main scale. Sorry, the number from the main scale that appears before the 0 mark on the vernier scale. So what mark do we have? The mark that we are considering, this is the one that appears before the 0 mark on the vernier scale. So what mark is there? Now you look at what we have. This is 0 and this is 1 in centimeters. So this would be 0.0, this would be 0.1, and this would be 0.2. So from the main scale, we have 0.02 centimeters. Because you can see that these readings are in centimeters, and this is a 0, this is a 1. So meaning 1 unit represents 0.1. That's why this is 0.0, this is 0.1, and this is 0.2 centimeters. This is from the main scale. What about on the vernier scale? On the vernier scale, we get the readings on the mark that coincides with the reading on the main scale. Therefore, the mark that we are talking about, which coincides, is from the main scale and the vernier scale, is this one here. Now we have to understand that these readings that are on the vernier scale are in centimeters and the millimeters, and therefore whatever we are going to get, we either just multiply by 0.01, or if you want first you divide by 10 to convert them to centimeters, then you multiply by the accuracy 0.1, the answer has to be the same. So if this is 0 and this is 5, therefore the mark represents a unit. This is 0, so this is 1, this is 2, and this is 3. So the first method is that 3 you get must be multiplied by 0.01, which gives us 0.03, and this will be in centimeters. If you don't want by that, to do that, you say, okay, this 3, let it be divided by 10 so that we convert from millimeters to centimeters. This gives us 0.3. So this is 0.3 centimeters. Now, this 0.3 centimeters that we have, you multiply by the accuracy, which is 0.1, and the resulting answer will be 0.03, which is the same as this one that we have here. So any of the two can work. Therefore, the readings will be 0.2 centimeters plus 0.03, and when we add this, we are going to have 0.23. So 0.3 centimeters, this is our error on the vernier scale. Therefore, the answer is D. Okay, that is what it means. Are we okay?
Yes.
Okay, so we go to the next question. The next question, which is saying, we have 4 objects. These 4 objects, we have object A, B, C, and D. And these objects, the particulars that we have are: 1, we have the gravitational field strength. We also have their masses. So the question is, for 4 objects E, F, G, and H of different masses were placed on were placed at places with different gravitational field strength. Which object will have the largest weight? What do we know? Weight is a product of mass times the gravity. Provided this mass is in kg and the gravitational field strength is in Newton per kg, because we know that weight is measured in kg, in newtons, so that the kg and the kg must cancel. So here you keep calculating, you see which one will give you the largest value. Let's start with the first one. The first one, when you multiply the 4, the 8 here, when you multiply the 8.0 by 0.4, it gives us the first one here. We have 30, we have 83.2 newtons. The second one here, when you multiply 8.5 by 9.8, 8.5 by 9.8, this one gives us 83.3. The second one, when we multiply 9.0 times 9.0 by 10.2, we have 91.8. All these are in newtons. Then the second one is 90.9.5. We multiply by 9.5. 9.5 by 9.5, we get to have 90.25. So from here, we can see that the largest weight that we have is 91.8. Therefore, the answer is C. So here it was a simple mathematics, because we thought that weight is a product of mass times the gravitational field strength, and we already see that the mass is in the right unit, so we just have to multiply, and then we get the largest value, which we get. Question number 2. Number 3 from section A says, a coconut drops from the top of the palm tree of height 20 meters. If the air resistance is ignored, how long will it take for the coconut to reach the ground given the gravitational field strength that? So here, what we need to do is we have to use the equations of linear equations, those linear motion, those equations where there's one says x is equal to ut plus half 18 squared, where how long we're talking about time, the distance is given, and A, this is the gravitational field strength that caused the object to start falling. Actually, this one was a free fall. Falling from a palm tree, no one threw it. Therefore, it was just falling on its own. So we're going to use this formula where the height is represented by x. We have 20 is equal to, because it was a free fall, the initial velocity there was 0. So 0 times t plus half. Then our a there is 10 and our t is squared. That's what we have. Then right from here, we can see that this and that can cancel, giving us a 5, so that we get a 20 is equal to, this gives us a 0, which we can even ignore. So there we only have 5t squared. Right from here, we can divide both sides by 5, so that this goes, and then our t squared is equal to 5 into 20 gives us a 4. Now we know that whenever we have a variable we are looking for which is squared, to eliminate the square, we introduce the multiplicative inverse of a 2, which is 1 over 2, also interpreted as a square root on both sides, so that these guys cancel, and then our t is going to be the number that you can multiply 2 times to give you 4 is 2, is plus or minus 2. Now, because we're talking about time, time should always be positive. That's why we have just picked on a positive 2. So meaning it only took 2 seconds for the coconut to fall down at the height of 20 meters. That's what the question was talking about. The next one is question B4. A4. A4 is talking about the uniform meter rule in equilibrium. The word here we're going to itemize is in equilibrium. What does it mean? It means this thing balanced, meaning the anti-clockwise moment and the clockwise moment should have balanced. They are equal. So because they are equal, what information do we know? Because they are equal, I'm looking for a bigger font. Actually. I think it's here. Oh yeah, it's here. Okay, let me get a bigger font. Thank you. So that's what it means. But we can see that moment is 2. There's a first moment here. Remember, the balancing is done from here. So the first moment is this one, where we can take this one as force 1, and the combination of these two, we take them as distance 1. Then we have this distance producing a certain moment also here. So actually on the left, you have got my moments here, be it. I've got moment 3. So the combination of moment 1 and the combination of moment 2 must be equal to moment 1 for as long as it's balanced. And moment 1 is also from the pivot up to where the x was. So remember, this is in mass, this one is in mass. This one is also mass, and they are all in grams. This one is in grams, and this one in grams, and the answer we are finding is in grams. So, meaning there is no need to convert that this force might be in newtons. We find its ways. We treat them the way they are. So, we are saying that moment 1 plus moment 3 must be equal to moment 2. Allow me to change this to moment 2. Yes. Now, what is moment 1? Moment 1, we are saying it's F1. It's F1 times the distance 1, which must be, then you're saying plus, then we'll have distance force 3 times the distance 3, which must be equal to force 2 times distance 2. So our force 1 is this mass. So force 1, this mass is 10 times. Our distance 1, also the distance is supposed to be in meters, but we can convert them the way they are because they are going to cancel. So because the pivot is from here up to the distance, so it's 30 plus 20, that gives us a 40. So this is the first moment. Plus the distance, the force 3 is this 20 grams. So we have 20 grams, which is multiplying the distance 1 from the pivot up to the line of action, it's 10. And we are saying that this must be equal to, the force 2 is this value here, which is x, which is multiplies our distance from the fulcrum here, the pivot, up to the line of action. This is actually 40. Then what do we do? So when you multiply here, when you multiply, you're going to have 400, 100 plus, when you multiply here, you're going to have 200. And we are saying that this must be equal to 4 times x, that is 40x. 40x. So when we add this part, we are going to have 600. So we'll have 600 is equal to, then here we've got a 40x, which we can divide by 40, both sides. We divide by 40, both sides. And when we divide, this goes there, 1, 0, 0, then 2 there, that's 2, 2 into 30, 2 into 60, that is 30. 2 there, 1, 2 into 30, 15. So the answer is that. So then here we had 15 grams. So most cases, people find it hard, especially to find the distance for the second moment, which is far off. The distance must be from the line of action up to the pivot, from the pivot up to the line of action. So meaning whatever distances were given here must be added. Then for this mass which is here, its moment must be the product of its force as well as the perpendicular distance from the pivot up to where the line of action. So that's what it means. So here the answer was 15. Can we move on?
Yes.
Okay. So question A5. The A5 says, a bullet passes through a wooden block of thickness. The thickness here is 0.8 meters. The speed of the bullet reduces from 700 to 300. meters second as it passes through the block. So the question is that if the mass of this block is 10 grams, what will be the work done by the bullet on the block? That's what the question is talking about. So how do you do it? We need to get our facts right, and the information that we're given here is enough. So how do you do it? We are given that we need to understand here that work done is measured in joules. Now, when the values are big, we can multiply, we can divide by 1,000 so that we can get the kilojoules that we have here. So meaning, when they say work done, any parameter that is measured in joules can be calculated representing the work done. Can be kinetic energy, can be the potential energy, can be just the work done, which is the product of force times distance, anything for as long as it is measured in joules. At times, the work done may be to do with the heat change. When you got the thermodynamics part of physics, to find that the work done at times it also got to do with the volume and the temperature. Such kind of thermodynamics calculations are performed. So for this one that we have, looking at the parameters, what we have the change of velocity. Okay, change of velocity. We also have the mass. The thickness here may be an constant function, may just be there to confuse us. So meaning the work done we're talking about is a potential energy, which is equal to half the mv squared. Now remember the velocity which is squared here, we have two velocities. There's v1 as well as v2. So the question is, are we going to subtract them? Then we are going to subtract them, then we square it, or are we going to square those individuals? Then we come and subtract them. That is what the question is to be understood. So let's look at the mass. This mass is in grams. When you convert this grams to kilo, kilo is a prefix which represents 1,000. So when you divide 10 by 1,000, we are going to have 0.01 kilograms. So meaning here, our mass will be 0.01 multiplied by this velocity here that we have must be squared. So we are going to say 700 squared minus 300 squared. Is what we're going to do. So that when we have this computed, we'll have half multiplied by 0.01 multiplied by the square of 700 must be 4,000. It's 490,000. Because these zeros will be squared twice. Remember what he told us, that when you're multiplying 10 times 10, just all you need to do is multiply these non-zero digits, which is 1, then count how many zeros they are, you add them. Bam. So meaning, when we are multiplying this part here, the space may not be enough. Allow me to move it a little bit on the left. So meaning here, when we are multiplying 1 over 2 here, multiply by 0.01. So meaning it's 700 times 700. So 7 times 7 is 449. So 49. Then the first 700 had 2 zeros. The second 700 also had 2 zeros. Minus 300 times 300. The 3 times 3 is 9. And then the first 300 had 1, 2, 0. The second 300 also had 1, 2 zeros. So this is what we have. And we can see that we have a 90,000. We also have a 90,000, which can be subtracted. So this gives us 1 over 2 multiplied by 0.01 multiplied by the 900 and the 900 they are subtracting, which gives us a 400,000. Yes. 1, 2, 3. Now, because this is mathematics, we understand we are far beyond this. So what we have here is that how many decimal places? We have 1, 2. So meaning we're going to remove 1, 2 zeros. And this part goes and this part goes. We are mathematicians. Then we are going to divide this half multiplied by what remains here is 4,000. So when you multiply half multiplied by 4,000, we are going to remain with the 2,000. So this was the work done in joules. But because the question is saying calculate in kilojoules, so meaning we are going to say that energy we have is 2,000 joules multiplied by or divide by 1,000 joules. You'll find that this goes, that goes, and that goes. And the answer remains 2.0. Therefore, the answer was B. So there was a lot of thinking here to apply here and there, but definitely at the end of the day, the truth has to prevail. So that's what you were supposed to do. The key thing here was, what do you do to the velocity? Do you say delta v squared? You say delta v squared, or is it v1 v squared should you say u v squared minus u squared, all those things? But the truth of the matter is that this should not be used. It is the final squared minus the initial squared. So because it started from here or reduced, yeah, so this is now our initial and this is our final, but definitely the modulus function must be taken so that the work done is positive. Questions? Hello?
No questions.
Okay, so we go to the next question, which is a question A6. Question X6 says an elevator ascends at a constant speed of 1 meters per second. Now we understand that constant speed, meaning the velocity is not changing, meaning there is no acceleration there, meaning the amount of force that is acting on it is the same as well. Yeah. But the truth of the matter there, what we're told is that the one that's constant is the velocity. So the total mass of the elevator is 1 kg. Calculate the power required to raise it to this speed. Now we understand very well that power is equal to work done divided by time. Power is the rate at which work is done. Now, what do we have here? We don't have time. The only thing that we have is the mass of the elevator. We are given the gravitational field strength. We are also given the speed at which this thing was moving. So from here, what else do we know about work done? Work done is force times distance. So meaning power is work done times distance, then we divide it by time. What about this weight? This is the gravitational, this is the weight. This is the force that we're talking about is the weight, or at times the force that's applied on the object. But in such a moment, because it was ascending, we're talking about weight against the gravity that this object was moving. How do you find the force? Force is equal to mass times acceleration. So meaning where we have force here, we are going to put ma times distance. Ma times distance. And then from here, so the only thing that you're supposed to do here, you have to do a little bit of derivation until you remain with the parameters that are given in the question. So here the next thing that we have to do, oh no,